Here's a significance test example. A candy company claims that 20% of its candies are red. To test this claim, a random sample of 200 candies was taken, and 35 of them were found to be red. Perform a significance test with a significance level of 0.05 or 5%, and determine what the company should conclude. Let's begin by identifying our null and alternative hypotheses. We're told in the problem that the claim is that 20% of the candies are red. So let's make that our null hypothesis, that our p-value is 20% or 20/100 or 2/10. The alternative hypothesis would be if p is not equal to 20% or 20/100 or 2/10. And P is the actual proportion of red candies made by the candy company. Next, let's check that the conditions are met before performing the test. The first part is the sampling method. Well, in this problem, they performed a random sample of 200 candies. So that is a valid simple random sample. So requirement number 1 has been met. Now requirement number 2 is the 10% rule. The sample size must be less than or equal to n divided by 10, capital N divided by 10. And it seems reasonable to assume that the company makes more than 2,000 candies within that period of time. And the last condition that we need to check is the large counts condition. Assuming that the null hypothesis is true, then our sample size times our initial p-value, which is 200 times 20% or 20/100, that's equal to 40, and n times 1 minus p initial is 200 times 1 minus 20/100, or 200 times 80/100, which is 160. And both of these values are greater than or equal to 10, so therefore all conditions are satisfied. Since the conditions were fully met, we can begin to perform a one-sample z-test for this proportion. First thing that we need to calculate is p-hat, and that's found by dividing the red ones by the total in our sample. So that's going to be 35 divided by 200, which is equal to 175 thousandths, if you actually use a calculator to divide them. Our initial p-value is the 20% or 20/100 or 2/10, and our sample size was 200. We can then substitute these values into our formula, and we're going to get 175 thousandths minus 20/100 divided by the square root of 20/100 times 1 minus 20/100 is 80/100, because that's easy to calculate, and then divide that by n, which is 200. And if we evaluate this into in a calculator, we end up getting about negative 884 thousandths. And the work shown on this slide verifies that we did indeed get the correct answer. Using a standard normal distribution table, we find that the p-value for this test is 377 thousandths, and since the significance level is 0.05, the p-value is greater than the significance level, so we fail to reject the null hypothesis. The final step is to draw a conclusion. Since our p-value was greater than the significance level, we do not have enough evidence to conclude that the true proportion of red candies is different from 20%. Therefore, the company's claim is not contradicted by the data at the 5% level of significance.